Small in size but immense in ambition, that is Singapore. With a land area of just 734 square kilometers, the country is building a port so vast it's visible from space. A project known as Tuas Mega Port. With a total investment of $20 billion, Tuas is designed to handle 65 million containers per year, surpassing the capacity of any port currently in operation anywhere in the world. So why would one of the world's smallest nations dare to invest tens of billions of dollars in an automated port project? How will Tuas reshape the flow of global trade? And what makes it fundamentally different from every other port on Earth? In today's video, Mandarin Tech will take you through these questions and explore how Singapore is building one of the most ambitious megaports in human history. Singapore is a country with a modest footprint on the world map, almost entirely lacking natural resources and constantly constrained by limited land for expansion. However, the island nation holds a crucial geographic advantage. It sits at the gateway to the Strait of Malacca, one of the busiest maritime routes on the planet. Each year, approximately 80% of the crude oil exported to East Asia, along with goods worth trillions of US dollars, must pass through this corridor. Positioned directly along this global commercial shortcut, Singapore gradually became a natural stopping point for merchant vessels, refueling ships, and intercontinental shipping lines. As early as the 1960s, Singapore regarded its seaports as a lifeline essential for survival and development. With no natural resources to rely on as a hinterland, the country chose to treat logistics services as its core resource, investing heavily in institutions, infrastructure, and cargo handling speed to become one of the most efficient transshipment hubs in the world. As global trade expanded rapidly, existing ports gradually reached their capacity limits. Faced with spatial constraints and intensifying competition, Singapore made a decisive, transformative choice to build Tuas Mega Port. Scheduled for completion in the year 2040, Tuas will become the world's largest automated container port, marking a shift into an era of digitalization and port operations run like a logistics machine of the future. Before the year 2015, Singapore's port system was operated as a collection of separate terminals and functional zones, including Jurong Port, Pasir Panjang Terminal, Keppel Harbour, and Tanjong Pagar Terminal. Tuas Megaport was conceived with the goal of consolidating all of these container ports into a single integrated hub, designed from the ground up to operate at a scale never seen before. The Tuas project is divided into 4 construction phases, with multiple phases implemented in parallel. The entire port is planned around a series of finger-like land extensions projecting into the sea, separated by deep water channels. This layout allows the port to receive and handle the largest container vessels in the world. Since its official opening on September 1, 2022, Tuas has processed approximately 10 million TEUs, while the total throughput of Singapore's entire port system exceeds 40 million TEUs per year. Under the long-term master plan toward the year 2040, Tuas Megaport will feature 66 berths with a designed capacity of up to 65 million TEUs annually, a figure far exceeding the current throughput of the Port of Shanghai, the busiest port in the world today. Spanning an area nearly comparable to Los Angeles International Airport, Tuas is not merely a new port, but a comprehensive restructuring of Singapore's entire maritime capacity. The first phase of Tuas Megaport did not begin with a massive foundation challenge beneath the water. To create a buildable platform, Singapore undertook an unprecedented land reclamation effort, using hundreds of millions of cubic meters of material, primarily sand and sediments sourced from multiple locations. Large-capacity dredging vessels operated continuously offshore, extracting sand from the seabed and pumping it directly into the planned area. This material was then spread and strengthened layer by layer to form a stable ground capable of supporting port structures weighing tens of thousands of tons in the future. The total reclaimed area in this phase reached 294 hectares, a scale rarely seen in coastal infrastructure projects. In parallel with land formation, a breakwater system extending more than 8.5 kilometers was constructed to protect the port from strong waves and marine currents. The entire ground level was raised by approximately 5 meters above mean sea level to account for the risk of sea level rise over the coming decades. While Phase 1 focused on establishing the initial foundation, Phase 2 was implemented as an expansion step to increase scale and complete the protective structure of the entire port. Beginning in 2019, Singapore continued land reclamation with an additional area of approximately 387 hectares, bringing the total port area to an entirely new level. In parallel, a larger breakwater system was constructed to match the rapidly increasing length of the port's shoreline. Instead of building seawalls using traditional methods, Tuas Mega Port employs caissons, massive watertight concrete blocks that are prefabricated on land and then precisely lowered onto the seabed. These caissons are connected continuously to form the retaining wall system for each finger-like land extension of the port, playing a core role in creating usable land and protecting the entire port area from wave action. Each caisson is about 28 meters tall, roughly equivalent to a 10-story building, and weighs up to 15,000 tons. This scale allows the structures to function like mobile foundation blocks, heavy enough to remain stable underwater, while still precise enough to be assembled into a continuous defensive system. In total, hundreds of caissons will be installed to complete Tuas's seawall lines. Caissons are cast entirely on land at dedicated fabrication facilities. The process begins with the base slab, the most critical component of the entire structure. Concrete is poured continuously and compacted using vibration to ensure maximum density and complete watertightness. Inside, the caisson adopts a box frame structural system to reduce weight while maintaining high strength. After each concrete lift, the slip-form system is raised using 36 hydraulic jacks, each capable of carrying loads of up to 1,500 tons, requiring near-perfect synchronization. Even a minor deviation could compromise the entire structure. During the COVID-19 pandemic in 2020, the production chain experienced severe disruptions. To recover lost time, the engineering team led by D.W. Kim reorganized the workflow, maintaining an average delivery rate of 8 caissons per month, with a workforce of approximately 2,000 workers operating continuously. Before leaving the fabrication yard, each caisson is coated with silane, a protective layer that enhances resistance to corrosion. Due to the toxic nature of this chemical, the coating process was redesigned to reduce health risks for workers. Once the casting process is complete, the caisson is pushed along a system of steel rails onto a floating berth, where it is prepared for its journey out to sea. Due to its exceptionally large size and weight, the caisson is not transported directly. Instead, it rests on a specialized floating platform designed to evenly distribute loads throughout the entire movement. 2 tugboats operate in coordination. One tug positioned at the front provides the primary pulling force, while the tug at the rear maintains direction and stabilizes the motion. The transport route is pre-calculated in detail, accounting for speed, wind direction, and ocean currents in order to minimize lateral movement. Throughout the journey, the caisson is continuously monitored to ensure that no twisting, misalignment, or collision occurs. The caisson installation phase is the most precision-critical step in the entire construction process. Before lowering, the location is determined using a high-precision GPS positioning system combined with on-site hydrographic survey data. Once the caisson reaches the exact coordinates, seawater is gradually pumped into the internal chambers, causing the concrete structure to sink toward the seabed at a carefully controlled rate. During the lowering operation, the caisson's position is continuously monitored to prevent lateral drift or uneven contact with the seabed. Upon touchdown, the caisson is aligned and connected to previously installed units. forming a continuous segment of the breakwater system. After several days of stabilization, the position is verified once again using GPS to ensure the caisson has been fixed exactly as designed before subsequent construction activities proceed. The subsequent phases of Tuas Mega Port are currently being implemented under a long-term plan. In Phase 3, Singapore plans to further expand the berths and complete supporting infrastructure in order to continue increasing the port's container handling capacity. In Phase 4, the focus shifts toward the deep integration of intelligent systems, with the goal of achieving comprehensive automation. Once completed, Tuas will not only expand in scale, but will also operate as a next-generation container port, fully prepared to meet global trade demands over the long term. How Tuas Port uses AI and automation. Compared to traditional container ports, Tuas Mega Port is participating in global trade in a completely different way. It holds the key to the future, not because it is larger, but because it is built around a core idea, allowing artificial intelligence and automation to orchestrate the entire operational rhythm of the port. Instead of each operational area running on separate processes, Tuas is designed as a closed ecosystem in which every movement is digitized. Artificial intelligence continuously collects and analyzes data from berths, container yards, and vessel traffic to make real-time decisions: which containers need to be handled first, which autonomous vehicles should move ahead, and which cranes are assigned to specific tasks. The goal is not only speed, but minimizing waiting time, the decisive factor in the efficiency of a global transshipment port. Within this system, automated cranes, unmanned vehicles, and surveillance drones do not operate as independent machines. They function as executing arms, following instructions from a central control hub. Instead of standing directly on the quay, humans shift into supervisory and intervention roles, using digital interfaces, visualized data, and supporting technologies to handle exceptional situations. One often overlooked benefit of this high level of automation is stability. The port can maintain nearly constant performance 24 hours a day, 7 days a week, with minimal impact from weather, shift changes, or workforce fluctuations. In a world where global supply chains are increasingly vulnerable to disruption, Tuas is not just a larger port, but a port designed to withstand continuous pressure over many decades. However, Tuas is not an exception to a rule called risk. With a project spanning several decades and an investment of around $15 billion, Singapore is compelled to account for long-term variables such as climate change and technological competition. The port's elevation has been raised and designed with safety margins to allow adaptation over time. Heavy reliance on automation also places high demands on system stability. Nevertheless, Tuas is built as a flexible platform that can be continuously updated and optimized, enabling the port not only to manage risks, but also to maintain its competitive advantage in the future. Global trade is changing rapidly, under pressure from rising costs, geopolitical instability, and increasingly strained supply chains. Nevertheless, around 80% of the world's goods are still transported by sea, and that is precisely the space that Tuas Mega Port is entering. By consolidating all container operations into a single smart megaport, Singapore can shorten transshipment times, increase stability, and maintain its role as a global logistics hub. This advantage allows Tuas to create a clear gap compared with competing regional ports such as Port Klang or Tanjung Priok, while also attracting additional international transshipment flows. More importantly, Tuas is driving a long-term shift in the port economy itself, from manual labor toward technical, coordination, and system management roles. In the long run, Tuas is not merely a new seaport, but a strategic piece of infrastructure that enables Singapore to remain connected to global trade for decades to come. Tuas Mega Port is the story of how a small nation like Singapore, with almost no natural resources, chooses to design its future through infrastructure and automation. Instead of expanding territory or searching for natural advantages, Singapore places its bet on a system built to operate reliably for decades, regardless of fluctuations in global trade. Tuas does not merely answer the question of how to handle more containers, but how to handle them faster, more consistently, and with fewer disruptions. If you want to continue exploring the infrastructure, technology, and engineering projects that are quietly shaping the modern world, please like the video, subscribe to the Mandarin Tech channel, and turn on notifications so you do not miss upcoming videos.